Okay, problems 3 and 4 from assignment A of this week. This was the one where we had these apartments. There were 9 floors, 4 apartments on each floor. Some had kids, some didn't have kids. And they were trying to get wear and tear on the carpet idea. The first question says they want to do a cluster sample. Do it. Describe how to do it. So cluster sample, remember, is all of some. So you group them first and then pick some of the groups and do every one of the groups. So since we want 8 rooms, there's 4 on a 4. I group them by rooms, or by floors, sorry, 1 through 9. I picked 2 numbers at random from 1 to 9 using a random number table. Those became my 2 floors. And then I checked all 4 rooms on each of those 2 floors to give me the 8 rooms to check. That's the cluster sample. Second part of that problem says let's do a stratified sample instead, and we're going to stratify the groups. So we're going to group them children or no children. And they said, what's the statistical advantage of this? And the statistical advantage of that is your guarantee. The whole idea of stratified sample is you ensure coverage, right? So you ensure coverage of rooms with both children and not with children. If you did the cluster sample, for instance, and got floors 3 and 6, let's say, there's no rooms with kids on 3 and 6, so you'd miss the kids' rooms altogether. So that's the whole idea of the stratified sample, right? Problem number 4. Just a straightforward 2-sample t-test. We got a little experiment. So when you're doing an experiment, your conditions are met by the experiment. You can just say it's a good randomized experiment. But make sure you use those words. It's a 2-sample t-test or difference of means. We got placebo group A, treatment group B, and we want to see if this one is basically more of a reduction than that one. This was the standard deviations. So my null hypothesis was the mean reduction for group A is equal to the mean reduction for group B, or mean 1 equals mean 2. I apologize, I did this one backwards. I don't know, I was thinking greater than. Probably should have done mean 1 is less than mean 2, but it means the same thing. If you did it the other way, everything's going to be on the left side. Test statistic will be negative, won't change anything. But my mean reduction for group B is greater than my mean reduction for group 1. Make sure you have a critical value. It's a 99% or 1% alpha, so all 99% to the left. So inverse T is a T distribution, 99%. 18 degrees of freedom, there's a 10 in each group, so 9 plus 9 is 18. Gave me a critical value of 2.55. I ran the test, just dumping those numbers into the 2-sample t-test. I got a test statistic of 1.61, a p-value of 6.2%. If you did yours less than, everything will be opposite, right? Negative, this will be the same. This would pop over here. We're going to fail to reject the null, which means there's no evidence that group B's reduction is greater than group A's. Even though it looks like it, and the main reason, right, is small sample size, right? If you had a bigger sample size, this would bump over this way, and you'd probably be at least closer, right? So anyway, that's the test. Some people asked about confidence intervals on these. You can only use a confidence interval for a 2-tailed test. If someone just said, is there a difference between these two, instead of running a test, if you wanted to, you could do a confidence interval. Just remember, if you do that confidence interval, you have to list the conditions and do everything there also. So that's it for number 4.